The connecting rod is one of the most critical components in an internal combustion engine. Also known as a BL, this mechanical link serves as the vital bridge between two essential engine parts. Here we can see actual connecting rods used in modern engines. Notice their distinctive shape. They have a large circular opening at one end and a smaller circular opening at the other, connected by a strong, precisely machined body. This close-up view shows the precision engineering involved in connecting rod manufacturing. The bronze-colored bushing visible in the smaller opening provides a smooth bearing surface for the piston pin connection. The connecting rod serves as the mechanical link in the engine's power transmission system. It connects the piston, which moves up and down in the cylinder, to the crankshaft, which rotates to provide power output. The primary function of the connecting rod is motion conversion. It transforms the reciprocating motion, the up and down movement of the piston, into rotational motion of the crankshaft, which ultimately powers the vehicle. Without the connecting rod, there would be no way to harness the explosive power of combustion and convert it into useful mechanical work. This makes the connecting rod an absolutely essential component in every internal combustion engine. The connecting rod serves as the crucial link between the piston and crankshaft, converting the explosive force of combustion into rotational motion that powers your engine. When fuel and air combust in the cylinder, the expanding gases create tremendous pressure. This explosive force pushes the piston downward with great power. The connecting rod is attached to the piston at its small end. As the piston moves down, the connecting rod transmits this linear force directly to the crankshaft. At the big end, the connecting rod is attached to the crankshaft. The linear motion of the piston is converted into rotational motion as the crankshaft turns. This mechanism demonstrates the fundamental principle of internal combustion engines. Explosive linear force is efficiently converted into smooth rotational motion through the connecting rod. Here we can see the detailed components of a piston and connecting rod assembly. Each part is precisely engineered to handle the extreme forces and temperatures inside the engine. The crankshaft is the final destination for all the power generated by combustion. Its precisely balanced design converts the reciprocating motion from multiple pistons into smooth rotational power. The connecting rod has a distinctive anatomy with two specialized ends, each designed for a specific function in the engine's operation. Here we can see the basic structure of a connecting rod. Notice how it has two distinctly different ends, the smaller end at the top and the larger end at the bottom. The connecting rod consists of three main sections: the small end, the shank or body, and the big end. Each part serves a critical role in the engine's operation. The small end connects to the piston through a component called the wrist pin or gudgeon pin. This connection allows the connecting rod to pivot as the piston moves up and down in the cylinder. The big end has a completely different design. It connects to the crankshaft and must handle much higher forces and rotational motion. This end uses precision bearings to reduce friction and ensure smooth operation. The big end consists of several precision components. The bearing cap is removable and held in place by high-strength bolts. Inside are bearing shells that provide a smooth, low-friction surface for the crankshaft to rotate against. The connecting rod must be incredibly strong to withstand the enormous forces generated during engine operation. It's typically made from forged steel or aluminum alloy, with precise machining to ensure perfect balance and alignment. The connecting rod's anatomy, with its specialized small end for piston connection and robust big end for crankshaft attachment, represents a perfect example of engineering design where form follows function in the demanding environment of an internal combustion engine. The connecting rod performs one of the most crucial mechanical conversions in an engine, transforming the linear motion of the piston into the rotational motion of the crankshaft. During the power stroke, combustion forces push the piston downward. The connecting rod, attached to both the piston and crankshaft, must transfer this linear force while changing its angle as the crankshaft rotates. The key to this conversion lies in the geometry. As the connecting rod pushes on the crankshaft journal at an angle, it creates a moment arm that generates torque, causing rotation. Once the crankshaft begins rotating, it reverses the process. The rotating crankshaft pulls the connecting rod, which in turn pulls the piston back up during the intake compression, and exhaust strokes. This continuous conversion between linear and rotational motion is what makes the internal combustion engine possible. The connecting rod acts as the crucial mechanical link that enables this energy transformation in both directions. In a four-stroke engine, the connecting rod plays a crucial role in each of the four distinct phases of operation. Understanding how the connecting rod moves during each stroke reveals its importance in engine function. Before examining each stroke, let's identify the key components. The piston connects to the connecting rod through the wrist pin, while the connecting rod's big end connects to the crankshaft. The first stroke is the intake stroke. The piston moves downward in the cylinder, creating a vacuum that draws the air-fuel mixture into the combustion chamber. During the compression stroke, the connecting rod pushes the piston upward, compressing the air-fuel mixture to create the high pressure needed for efficient combustion. The combustion stroke is where power is generated. The spark plug ignites the compressed mixture, creating an explosion that forces the piston down. The connecting rod transfers this powerful downward force to rotate the crankshaft. Finally, the exhaust stroke clears the cylinder of burnt gases. The connecting rod again pushes the piston upward, forcing the exhaust gases out through the open exhaust valve. Throughout all four strokes, the connecting rod ensures precise piston movement. It converts the rotational motion of the crankshaft into the linear motion needed for each stroke, while also transferring the combustion power back to the crankshaft for useful work output. Modern engines use multiple cylinders, each equipped with its own piston and connecting rod. These components must work in perfect coordination to deliver smooth, balanced power. Each connecting rod connects its piston to a specific position on the crankshaft called a throw. The crankshaft throws are positioned at different angles to ensure smooth power delivery and engine balance. The firing order determines which cylinder fires when. This sequence is carefully designed to minimize vibration and maximize engine smoothness. In a typical four-cylinder engine with firing order 1, 3, 4, 2, the cylinders fire in this specific sequence. This creates evenly spaced power pulses every 180 degrees of crankshaft rotation. Here we can see the actual internal components of a multi-cylinder engine. Notice how multiple pistons and connecting rods are arranged along the crankshaft. Different engine manufacturers use various firing orders and cylinder arrangements. Each configuration is optimized for specific performance characteristics and engine balance requirements. The coordination of multiple connecting rods in multi-cylinder engines is essential for smooth operation. This precise timing and balance allows modern engines to deliver consistent power while minimizing vibration and maximizing efficiency. Connecting rods are precision-engineered components that must meet three critical requirements to function effectively in an engine. These requirements are strength, precision, and weight optimization. First, connecting rods must possess incredible strength. During each combustion cycle, they experience tremendous forces from high-pressure explosions in the cylinders, often exceeding several tons of force. Second, connecting rods require extreme manufacturing precision. Tolerances must be maintained within thousandths of an inch to ensure proper engine timing, balance, and smooth operation. Third, connecting rods must be lightweight to minimize inertia. Reducing reciprocating mass allows the engine to rev faster, operate more smoothly, and achieve better fuel efficiency. These three requirements, strength, precision, and weight, must be carefully balanced in connecting rod design. Modern connecting rods use advanced materials and manufacturing techniques to achieve this optimal combination of properties. The connecting rod stands as one of the most critical components in any internal combustion engine. Despite its seemingly simple design, this component serves as the vital link that makes engine operation possible. Without the connecting rod, the explosive energy from combustion in the cylinder would have no way to reach the crankshaft. The connecting rod is the essential bridge that captures the linear motion of the piston and transfers it to create rotational motion. This energy conversion process is what ultimately drives your vehicle. The rotational motion created by the connecting rod and crankshaft system travels through the transmission to the wheels. propelling the vehicle forward. The four-stroke engine cycle demonstrates just how integral the connecting rod is to engine operation. In every single stroke, intake, compression, combustion, and exhaust, the connecting rod is actively transferring forces and motion. Consider what would happen without the connecting rod. The piston would move up and down uselessly in the cylinder, unable to transfer its motion to the crankshaft. The engine would be completely non-functional. No power, no rotation, no movement. The connecting rod's importance cannot be overstated. This single component enables the entire engine to function, converting explosive energy into the smooth rotational motion that powers our vehicles. Its simple appearance masks its absolutely critical role in modern transportation.